just a quick example of how to use the cosine rule to find the unknown side. Right? And we've got this long formula here, but the thing to realize is that this expression actually looks quite familiar. It looks kind of like your Pythagoras theorem, kind of on steroids. There's a bit of an extra bit there, and that's to account for the fact that we're not dealing with right angle trigonometry anymore. Right? So I've got c squared equals to a squared plus b squared minus 2ab times cos c. And basically, the essential thing to realize about this equation here is that the positions of a and b, you realize they don't matter, right? Because these order of operations, if I swap them around, if I swap the values around, they don't affect the final value. And that's because a and b are the values of these two sides here. A and b are the sides next to the given angle. Okay? So we say adjacent or next to the given angle, and side C here, well that little c has to be opposite your big C, which is that angle there. Okay? So C is the side opposite the angle. And that's really the most important thing when we're thinking about substituting values into a formula. Really need to know how we actually approach this and what values we put into our expression here. So once we realize that, let's go ahead and do it. I know that c squared is equal to a squared plus b squared, so 10 squared plus 6 squared, minus 2ab, or 2 times 10 times 6, times cos 76 degrees. Good idea when you're writing these out when you're evaluating your calculator, put in that whole expression. So I get 106.9693, this dot keeps on going. And at this point, students often kind of leave that as their answer because they found it, like, yeah, I found the length. But you want to be doing some error checking in your head, right? Because if this is 10 and this is 6, it doesn't really make sense that that's 106 point something. And what I forgot to do is I take the square root, because that was what c squared is equal to. I need to find what c is. Once you take the square root of that, you get 10.342, and that's just 10.34. No units there, it was units to 2 dp. Okay? And if you swap the 10s and 6 values around, you'll notice that that won't affect the final value of your expression. Cool. That's one example of cosine rule. Pause the video now and have a go at this one. We've got another example. It doesn't matter that if we change these values around or we add in degrees and minutes, we can still use the cosine rule to solve this one. Do that for you guys. So same idea here. We've just changed the variables. I've got x here instead. But remember, what do I want? Where do I want to put x? Well, x is my unknown value, and it's opposite that angle there. So that's going to be my subject. I'm going to have x squared is equal to, say, 38.1 squared plus 64.5 squared minus 2 times 38.1 times 64.5, kind of running out of room, times cos of this. So cos 58 degrees, 34 minutes. Okay, kind of went over there, that's okay. Let's evaluate that. And get 3048.709. That's the one. And remember, I need to take the square root, so that's going to be 55.215, or just 55.22. Yeah, no units, so just write some units in there. That's the 2D decimal places. So really the most important thing to note here when you're using the cosine rule, just be aware of what are A and B. Well, those are the side lengths which are adjacent or next to the angle that you're given, and C, or whatever variable you've been given, has to be opposite that angle. And that's cosine rule for unknown side.